film 2 out of 3 on static characteristics of measurement systems. It's a bit long, this topic, so therefore I split it into 3 films. And this one is about environmental effects. And environmental effects is not like the threats to the environment. It is the environment where you find the measurement systems. So they stand in an environment and say that one measurement system is designed to measure pressure, for example, the pressure within a tank, and the environmental effects that also affect this instrument might be the outside temperature or humidity or vibrations or whatever that might also influence the readings from that instrument. So this effect, the environmental effects, they are undesired. We don't want them to be present in our measurement system because we want the measurement system to do one job, and that is to measure what it's designed to measure. For example, the pressure transmitter that I talked about a few seconds ago. We want it to detect pressure. We don't want it to detect the ambient temperature or whatever is outside the measurement system. Having said that, it's almost impossible to design a system that is absolutely insensitive to every environmental effect that is around the instrument. Most instruments are influenced in 2 different ways. You have what is called a modifying environmental effect, which is when the sensitivity of the system is influenced by this system. So let's say that you have the lower line here. That is when you have, for example, the pressure transmitter at a standard ambient temperature, and that would typically be 25 degrees Celsius. Now, if the temperature increases to, let's say, 50 degrees Celsius or even 75 degrees Celsius, well, that would, if you have a modifying environmental effect, that would influence the sensitivity of the system. On the other hand, interfering environmental effect, interfering in Norwegian is forstyrrende. So if you have an interfering environmental effect, that would influence the bias. So you have a parallel line here. Let's say that this one is at an ambient temperature of 25 degrees. If you increase that ambient temperature to 50, and remember, you still want to detect pressure. It's a pressure detector, but the outside temperature, the temperature just outside the measurement system changes. If it goes to 50, that output would increase, and even more if it goes to 75. So you have a parallel change in the input-output relationship. So the full equation now becomes, you have this original here, the output is K times I plus A, that is the sensitivity multiplied by the input, plus the bias. Then you have the nonlinearity, the function n of I, and then you have the modifying environmental effect, Km Im times I, and then you have the interfering environmental effect, Ki times II. So what are these elements here? Well, the I is the good old input that we had over here as well. Let's keep that example with a pressure transmitter. So this is the input here is the pressure which is the input to the system. The Im is the other input. Let's say that would be, for example, the ambient temperature. And Km is how sensitive are you to this other input. So if this here illustrates the modifying environmental effect, if these three lines really fan out, that they are spread far apart from each other, that would mean that you have a high Km. It's very sensitive to the environmental effect. Ideally, that one should be 0. So it should ideally be non-sensitive to these modifying inputs. Or if you can't make it insensitive to modifying inputs, maybe you could try to control that. So you have a pressure transmitter somewhere. You know that it's really sensitive to the modifying environmental effect. Well, then you can try to keep the temperature about it stable. Have a stable temperature, and that means that the modifying environmental input here or effect is reduced. Same here. Ki is how sensitive are you to this interfering effect, and how much interfering do you have. So let's say one example here is that you have a pressure transmitter. It is sensitive to temperature as well, and humidity. Then maybe this one could be temperature, or this one could be humidity. Also, you could have that the temperature does both. If you increase the temperature, both things happen simultaneously. But then the Im would be how much, or Km, how much of that effect and how much of that effect interfering. So the two of them, Im and II, can be the same, but they can also be different. So two different things, two different elements that influence the system like this. Ideally, the nonlinearity should be 0, the modifying effect should be 0, the interfering effect should be 0, but in a real world, we have them all.